Hi students, today we'll see as a part of 8th CBSE curriculum a chapter called Force and Pressure. We'll see the definition of force, different types of forces, and what exactly pressure is, how pressure can be derived from force and area, and other things. So in a day-to-day life, where we encounter these things and different types of forces like balanced force, unbalanced force, and pressure also. Finally, we end up with the atmospheric pressure, what exactly the definition of atmospheric pressure. So let me take you through different slides of the chapter. So we'll start with the PPT, PowerPoint presentation based on that. Let me share for that. So here you can see, you can see force and pressure. So there are some pictures shown here. No, you can observe all these. All of you please observe these particular pics. So what did you observe? First pic, a man is pushing a particular vehicle. In the second pic, right, in the down, so a sports person is just pushing the ball with the bat. Next thing, in the similar way, in the sports, in the same games and sports, particularly in the game of football, one is just pushing the ball, hitting the ball hard. In the second column, you can see one is just pulling the cart. The same way, a woman is being pulled by a horse, okay, in the cart. And finally, the game of tug of war. You can all see in this. So then, looking at these pics, how do you define force? So can we define like force is either push or simply pull? Yes, we can define force in the basic terms as either push or pull of on an object. So push or pull on an object is said to be force. So if an object has to be moved, definitely it must be either pushed or it must be pulled. So in all the cases that you are seeing in the pictures, so there is some kind of force, whether it is push or pull. So in the first case, actually he is actually pushing the car. Now in the second and third case also, they are just pushing the balls, right? And lateral here, actually in the second column, that is, you can all see the pulling part. So in different ways, actually, how pulling can be employed. So in the tug of war, so the one side actually is pulling. So this push or pull is said to be the basic definition of force. Next thing is, so that's what I just told you. It is forces are basically due to what? So we can say it is if whenever force we encounter a force, they are basically forces are basically due to interaction. If there is no interaction, force cannot be there. So an interaction of one object and another object results in force between the two objects. So unless and until one object is interacting with the other object, we cannot have any type of force. Like here, the man is pushing, so he's interacting with the vehicle. So that way, he's pushing the vehicle, and that is the reason why. So forces are basically due to interaction. We can say, like man standing behind the car, and car doesn't move simply. So if he pushes the car only, then he applies force, and the car begins to move in the direction of the applied force. Next thing. Now, if you explore forces, actually, what kind of forces do exist? Whether they are all balanced forces, or as what is actually the movement? The movement comes with a balanced force or unbalanced force. That way, if you study, in the first case, you can see in the picture actually when we have forces, two forces here are being applied on an object of mass, say mkg or something. So here F1 is one force and F2 are other force. Both are acting in the same direction on the object. So when two forces are acting on the object in the same direction, so always the net amount of force that is resulting of because of which the resulting movement will be there. Like you can see here, the net force is only they'll be added. So when you calculate the net force here, both the forces they add to each other to result in a combined force. So with the combined force, actually the particular object moves in the direction of the push, like because F it's going to be a push only for both the forces. So in the direction of push. So that's why you can say if two forces act on a body in the same direction, the net force is the sum of the two forces. On the other hand, when two forces are acting on the body in opposite directions, right, you can see in the second picture. So now the net force is the difference between the two forces. And finally, the magnitude of the forces that matters a lot. Here, F2 seems to be slightly greater than F1, and that is the reason why the resultant force will be in the direction of F2 only, not F1. You can see the magnitude wise, there is a difference like the magnitude of F1 is seems to be quite less than that of F2 when you calculate the length of that vector. So therefore, it is net force is equal to F2 difference F2. Now we can say something here. The effect on the object basically depends on the net force acting on it. So because cause simply just because of cause we have to see the effect. So effect on the object depends on the net force acting on it. So end of the day we have to calculate the net forces because not only in one direction forces can be applied or may be applied. So in different directions forces may be there, as a resultant of which final direction we can expect some momentum or there is a displacement. Now we can see next thing like effect of force on an object. What kind of effects will be there? Like the first thing is force can make an object to move from rest. As we have seen in the previous slides, force can really make up an object from move from rest. So when an object is there in the state of rest, as we studied in the Newton's first law, so when you apply some force, unbalanced force, it changes the movement. It changes the position. Like next, force can stop a moving object. That's what you can see in the second picture. That is, so the man is exerting some force. The goalkeeper is exerting some force to catch hold of the ball, and he is stopping the ball without going to the net. So here the force can stop a moving object. That way force can be there. Okay. So one thing, first case we have seen force makes an object to move from rest, and the second case we have seen force can stop moving object. In the third case, actually force can change the speed of an object if it is moving. So what is the most appropriate picture that is applicable to here? Force can change the speed of an object if it is moving. Now here actually in the case of cycling, so the sports person actually who is doing the cycling, so when he just stops at the this one at the destination, automatically it comes to standstill after a few minutes. So here it can change the speed of an object. So because when you apply some forces, automatically it comes to rest. Like even while applying brakes also comes under this category. So that's why it comes object can come to rest also. Force can change the speed as well. So third case we are looking at the speed. So force can change the speed, and force can change the direction of motion of an object. So here in the fourth picture, actually in the game of cricket, so you can see so the direction of the ball bowled by the bowler. So it is being changed. So you can see the batsman actually he's changing the direction of the ball. So he's just flicking the ball in the direction. So therefore, it's in the clicking of the ball, actually flicking of the ball. So the direction of the ball will be changed, right? So that's what the batsmen generally do. Batsmen generally do to get fours and sixes and better runs for that. Now, fifth case being actually, so fourth is force can change the direction of motion of an object, and finally force can change the shape of an object. So here we can see very much the lady actually making a homemaker is doing some chapatis and rotis. So here the shape of an object is also being changed. So this way force may cause one or more of these effects. So when a force is there, it may cause one effect or it may cause so many effects parallelly. Next thing is you can see the types of forces. So far we have seen the effects of the forces. Now we'll see the types of the forces. There are basically main types of the forces, that is contact forces and non-contact forces. So even you can observe actually out of our experience. So we might have experienced so many instances wherein sometimes we apply force, we will be in contact with the force, and sometimes we will not be in contact with the force. So what are the forces that are in contact? Like forces exerted by an object and another object are in contact. So like muscular force and force of friction are the best examples. So these will be there. So the next slides will exemplify you like force of friction also, because in both the cases contact is necessary. So in friction also it is opposite force that resists the movement of a body and sliding of a body, rolling of a body on another surface. So here, there actually there must be a physical contact, and particularly while jumping in the case of games and sports, muscular forces will be applied, so they will be also in contact. So thing is that, so what are then the other forces which are called non-contact forces? So forces exerted by an object and another without any physical contact, it is said to be non-contact forces. Like we have magnetic force, we have electrostatic force. So we have magnetism. We have might have studied or will be studying in the next higher classes. So we know that whenever a magnet is brought near to an iron piece, it will, or iron pins, it will attract without any physical contact. So that is what is called magnetic force. And electrostatic force of attraction. So particularly an object when it's continuously rubbed on another object, okay, like a straw or a silk saree or whatever it may be. So it gets some electrostatic forces, like electrostatic forces they get applied there. So as a result, actually, you can observe whether force of attraction and repulsion. Finally, we have gravitational force also. That is, so here there is no physical contact at all, even in the case of gravitation. So Earth will attract each and every object that is there in its atmosphere or in its neighborhood. So acceleration due to gravity being around 9.8 meter per second square. So we can say it is also a non-contact force. Next thing is, so here you can see contact forces, that is, as I just said you, the first one we can see muscular forces, the force exerted by the muscles of our body. So here actually the sports person in both the cases, so they are applying some muscles of the body. So we use muscular forces for various activities like animals. Now animals like bullocks and horses, camels, donkeys, they all use muscular force to perform various tasks. Horses generally used to pull the carts, camels in the similar way. Now donkeys, elephants, and ewes, they all use muscular forces to perform various tasks. Okay, then we have a force of friction. So here you can see a ball actually on the ground. So force of friction is the force which opposes the motion of an object over a surface. So yes, so force of friction is a force which opposes the motion of object on a surface or over a surface. This friction part we'll study in detail in the next coming videos, like where we study friction. So here actually, so friction force also actually, it is also a contact force. So only because of contact friction that exists between the surfaces. Okay, when a ball is sliding on the surface or on a grass, this one, right, in a field. So because of the surface and the irregularities on the surface, so it comes to standstill. So that's what. So ball rolling on a ground gradually slows down and comes to a rest due to force of friction. So like we stop pedaling a bicycle also, you can see in the next picture that once we stop pedaling a bicycle, it gradually slows down and comes to a stop due to force of friction. So if friction is not applied, you cannot even stand, you cannot even run, even we cannot write on with a pen on a book. So that is that much very important friction force is. So here once he stops the pedaling, gradually slows down because of the frictional force that exists between the cycle tires and the road. So where irregularities are present, and that is called force of friction. The thing is that next you can observe some non-contact forces, as I just mentioned you. That is magnetic force is one of the main forces, like force of attraction or repulsion that exists between poles or magnets. Like you can see force is exerted by a magnet and a piece of iron and steel. So here you can see in this picture actually some pins, iron pins are there, which are being attracted with the magnet towards the magnet. So that is what, without any physical contact, it is only non-contact force. So here also you can very much see, because North Pole and South Pole are there side by side. So there is a force of attraction between opposite poles. So between opposite poles, there will be a force of attraction, and here also you can have between South and North another force of attraction. But between two Norths, always there exists a repulsive force, and finally between two Souths also you can have a result repulsive force. This is how actually non-contact forces they play a role in our life. Right. Next thing is, as I just told you, electrostatic forces actually. So you can observe very easily. This is the small activities you can do, like a charged body, particularly the force exerted by a charged body and another charged body or uncharged body is said to be electrostatic force of attraction. So a plastic straw, simply because you can see in the figure, simply a plastic straw is charged by rubbing with paper. No, it attracts a suspended plastic straw again. So here it is a plastic straw, and this will be attracted towards this plastic straw because of the electrostatic force. Similarly, it can repel also at times. So plastic straw charged by rubbing with paper again repels with suspended plastic recharged by rubber, rubbing with paper. So that's what. So if it is a mere plastic straw, see once a plastic straw charged by rubbing with paper, if it is only in the first case, it's a mere plastic straw charged by rubbing with paper, and the other one we have taken only as a plastic straw only without rubbing any. So there exists a force of attraction. When both things are same, actually they will be repelled. So that's how it is shown here, repulsion. So finally, some gravitational forces you can see very much. There are very good examples over here. It is a force exerted by the earth. So the gravity word refers to earth, and gravitational force is caused due to earth. So it pulls all objects towards the earth. So that's you can see different cases like a coin or pen falling down when it slips off your hand. So here the persons are, you can see here pen or this one, like a pen falling down when it slips off your hand. Then similarly a ball thrown upward again it also comes, a ball thrown upward it again. This is what you can see, it is falling down. So because of continuous gravitational pull, so though it is going up, actually it will be under the influence of the force, gravitational force. And finally you can see over here the person throwing some ball or even a pen, that how it comes down. So leaves and fruits also, they fall to the ground when they get detached. So we can see in these seasons, so from the plant actually the leaves and fruits they fall. So water in river also flows downwards only because, yes, always that is also because of this one. And finally you can see some yeah, parachutes, and they are coming down because of the gravitational pull. So yes, next thing is, lastly we can see what is pressure. So it's a very important physical parameter which is derived from force and area. So pressure is, we can define pressure as the force acting per unit area of the surface. Now let us take some examples. So if the area is smaller, obviously you can see, look at the denominator and numerator. So denominator is area and numerator is force. So if the denominator portion is high, the pressure will be less. Because and similarly, if the denominator portion is less, area is less, pressure will be more. So we use this principle in generally in the household domestic items as well. So it is very easy, as an example you can see, it is very easy to push a nail into the wooden plank by its pointed end, because the surface area is very less with the pointed end. But when it comes to the head, it's very difficult to send it the entire head, because it's more area of cross section, more area of exposure. Similarly, we can also cut vegetables with a sharp knife than a blunt knife, because of the pressure is more. So exposure area is less in the case of sharp knives. So as a result, actually the vegetables will be cut very easily. And finally, we have shoulder bags have broad. Right. Similarly, we can also see like shoulder bags have broad and not thin straps to reduce pressure. Yes, what are the pressure that is there? So pressure will be, it will be reduced automatically when bags have broad um, and thin straps, because the area of exposure must be less, right? So then pressure exerted will be less. Now finally, we can see pressure exerted by liquids and gases. So this is another thing, like we have to observe here, whether do liquids exert pressure or not, or even only solids do exert pressure. No, not only solids, the other forms of matter also exert pressure, that is liquids and gases. So liquids exert pressure on the walls of the container. So you can see there are some few examples we have, like practical activities. So liquids, they exert pressure on the walls of the container, because liquids they get the shape of the container in which they are present. So obviously they exert pressure on the walls of the container in which they are present. So liquids exert pressure on the bottom of a container. Both the things we can see, it depends on the height of the liquid column. If the height is very more, we can also have on the bottom of the, yes, on the bottom of the container. So it depends upon the height of the liquid column. So you can see liquid column is high in this case rather than this. So finally, liquids exert sideways pressure, that also you can see over here. If there is an opening here, so sideways pressure also they exert. And finally, liquids exert equal pressure at the same height. So if you just make some holes over here, So there will be equal pressure will be equal at equal levels, like at the same height. So at the same height, they exert equal pressure, and as a result, the quantity of water that comes out also will be the same. Now, finally, see pressure exerted by the gases we see, and then we'll go forward to atmospheric pressure to wind up. So gases exert pressure on the walls of the container. So far, we have seen with the liquids. So in the similar manner, gases also exert pressure on the walls of a container. You can see a tube actually filled with air. So in an automobile shop, right? So here also the gases do exert some pressure on the walls of a container. You can see the balloon. You can see with respect to this one swimming, the bags used in swim. So therefore, there actually these bags are all water, these air bags. So yeah, they are all filled with some air or some gas. So gas also they do exert pressure on the walls of the container because they don't have a specific shape. Finally, we see now what is atmospheric pressure. As the name implies, atmospheric pressure is the pressure of air around us. Like what is the pressure being exerted on us by the air? So atmospheric pressure is due to the weight of the air, same. So force per unit area. So weight of an air column of the height of the atmosphere. See carefully here. The weight of an air column of the height of the atmosphere. Uh, Again, the weight of an air column of the height of the atmosphere, like an area 10 centimeter and 10 centimeter is as large as 1000 kg. So here we should observe one point here, like height of the atmosphere, like area just 10 centimeter by 10 centimeter. If you just cuboid you take, so the volume if you look at actually, so what are the pressure exerted? Okay, so so exerted in the pressure exerted in a cuboid like with 10 centimeter by 10 centimeter, that is air column. You can say you can take either cuboid or you can just take a rectangular, this one, two-dimensional case. Like simply the weight of an air column of the height of the atmosphere and area 10 centimeter by 10 centimeter. It is as large as 1000 kg. So it's very high because, okay, so because the area is less, obviously pressure will be more. So some of the examples include rubber sucker and this air column and all. So this is way actually we can also have a picture which is taken long back, like in the previous eras. So that's we come almost to an end, and yes, so we have so far learnt force and pressure, different types of forces, contact force and non-contact forces. Then we have defined pressure and different types of pressure. So with that, we come to an end of the chapter. Thank you.